Hello there. I hope everyone's having a good day. We've been working with trig functions, and today what we're going to do is we're going to look at what a graph of a trigonometric function would look like. The document you have is called Exploring Periodic Data. So we're going to talk today about both sine and cosine functions. Those are the ones that we're going to look at, and we're not going to have time to do more than sine and cosine functions. So just so you understand that, this is all we're going to be looking at. With exploring periodic data, a period function is a function that repeats y values. As your x values go, your y values or your output data is going to be the exact same at a regular interval, right? One complete pattern is a cycle, and a cycle can begin at any point on the graph of a function. Okay, it's kind of like a circle. If you start at 12, you go back to 12. If you start at 3, you go back around the 3. It's a cycle. It is a pattern. The period of a function is the horizontal length of one cycle. Periodic behavior is behavior that repeats over intervals of a constant length. So let's look at some of these down here. You can see this first little graph. See how it starts and then it comes right back down, and it starts and it comes right back down. A heartbeat on a graph. You will look at that and that will do the same thing. Here is one cycle. In red, we have one cycle. It starts up here. Doesn't matter where we are. We can start it at the highest point and it goes back to the highest point, and then it's going to start again. The period goes from 2 to 6, so 4 units. Let's try it again. If we go from the x-axis, we go from here all the way down and back up to here again, okay? This is from 8 to 12. It is still 4 units. There are other ones here for you to try to see if you can figure out what the period of those are. Down here, we're asked to determine, is it periodic? Look at this. No, it's not periodic data. So I just put a no and we go on. If we do see that it is a periodic function, we're asked what is the period of the function. So if we're looking at this one, it starts up here at 2 and it comes down, and as it goes back up, and we can see that it is a periodic function. Okay, so yes, this is periodic because it's going to repeat, and and it repeats over 10 units. All right, you do the other two over here. The amplitude is the next thing that we're going to look at. The amplitude is the amplitude of a periodic function measures the amount of variation in the function values. The amplitude can be found by the distance between the maximum and the minimum values and dividing it by 2. This amplitude is a whole lot easier to come up with than the distance formula. It is half of the maximum height, subtract the minimum height. So if we're looking here, our maximum height here is 4. Our minimum height here is, what is it? Yeah, 2. So it is 1/2 of 4 minus -2. So it would be 3. 1/2 of 6, 3. That would be our amplitude, right? So those are very easy. So you can do these down here and find out what is the amplitude of the function. My amplitude is going to be 1/2. The highest value I have here is 2 minus 0. 1/2 of 2, my amplitude is 1. So my amplitude there is 1. And then you have some to try. We are truly only going to go over the basics of trig functions. I will give you something later on for you to look at sine and cosine functions in a Desmos activity, just really to have fun with. Because since we're not together, it is difficult to practice these together. So if I have a sine function, it looks like this. Y is equal to A, the sine of B theta. Cosine is the same. Y is equal to A cosine of B theta. If I'm looking at a sine function, what is the sine? What is the Y value of 0? 0. Okay? And at 90 degrees at pi over 2 on our unit circle, the sine is 1. At 180 degrees or pi, it is at 0. At 3 pi over 2, 270 degrees, the sine value is negative 1. And then back up to 2 pi or 360 degrees, it's back at 0. So you see how it makes a periodic function. The cosine value starts at 1 and it repeats all the way back to 2 pi. So here's some key ideas over here. The absolute value of A, which is your is the amplitude of this function. This is the absolute value of A will be the amplitude of the function. All right. The B is the number of cycles in an interval between 0 and 2 pi. Okay. Between 0 and 2 pi, B is the number of cycles. Right? And then your period of a function, because we're going to be asked what is the period of a function, is 2 pi over B, over whatever this value is. So let's look at example 4. All right, find the period of a sine curve. I'm told that it is a sine curve, and write the equation of a function. So the period here, it goes from 0 and it goes all the way back up here. So this is pi, here's 2 pi. So the period of the function is 2 pi. My amplitude, remember my formula, is 1/2 the highest point, 2, minus the lowest point, which is negative 2, 1/2 of 4. The A value, my amplitude, is going to be 2. And the B, okay, how many cycles between 0 and 2 pi? It completes 1 cycle. So if I'm going to write the equation, Y is equal to the A value, 2. We're told this is a sine function, so the sine of theta. My B value is 1. Put that in there. I would like for you to do the other 2 examples on this page. Find the period, the amplitude, your A and B values, and write them. This is a sine curve like we were doing. And here is just a cosine curve. So all you're going to do is write cosine. You're going to do it the exact same way as a sine, except write cosine instead of sine. I hope that this helps, and I will be here between 10 and 11 and 2 and 3. Have a great day.